Hey everyone, welcome back to our channel. Today we are diving into an exciting topic that's haloalkane and haloarine, and by the end of this video you will know everything about their types, properties, reactions. So let's get started. First, let's understand what haloalkane are. Haloalkane are the derivative of alkane formed by the replacement of hydrogen atoms by halogen. The halogen might be fluorine, chlorine, bromine, and iodine. The general formula of haloalkane is CnH2n plus 1x. It is also known by alkyl halide. They are famous in organic chemistry as they show nucleophilic substitution reaction. The physical properties of haloalkane is first one is boiling point. Boiling point of haloalkane is directly proportional to size of halogen attached to it, and for the corresponding alkene, the boiling point of haloalkane is greater than that of corresponding alkane due to carbon and halogen bond. Second one is solubility. They are insoluble in water, but they are soluble in organic solvent like benzene due to diffusion. Third one is density. Density is also directly proportional to size of halogen atom attached. And now the second one is chemical properties. First, let's understand about nucleophilic substitution reaction. Whenever the halogen goes nucleophilic substitution reaction on or ANSR, the halogen atoms get replaced by some nucleophile. It has two mechanisms. First one is SN1 reaction and second one is SN2 reaction. SN1 reaction is unimolecular reaction, whereas SN2 reaction is bimolecular reaction. SN1 gets completed in two steps, whereas SN2 gets completed in one step. SN1 is an example of first order reaction and SN2 is an example of second order reaction. Formation of carbocation happens, but it doesn't forms in SN2 reaction. For SN1, the reactivity is directly proportional to stability of carbocation formed. For SN2, as the carbocation doesn't form, that's why reactivity is directly proportional to reciprocal of hindrance. For SN1 reaction, tertiary haloalkane are more reactive. For SN2, primary are more reactive. Now let us understand about the preparation and the reaction or chemical properties commonly shown by haloalkane. Haloalkane can be produced from alkane by halonation. Halonation of alkane is a reversible reaction, so it is carried out in the presence of oxidizing agent like HNO3, HiO3, etc. It can also be prepared from alcohol by either treating it with Lucas reagent or treating it with PCl5 or from the Dargent's method. Haloalkane when reacting with potassium hydroxide, if the potassium hydroxide is in aqueous medium, it forms alcohol. When the potassium hydroxide is acidic, it produces respective alkene. This reaction is commonly known as beta dehydrohalogenation reaction, as the halogen gets removed from beta position. If a halogen goes Williamson's reaction, it forms ether. If haloalkane reacts with KCN, it forms cyanide. While it reacts with AgCN, it produces isocyanide. Haloalkane reacts with AgNO2, it forms nitroso compound, but if haloalkane reacts with KNO2, it forms nitro compounds. When it reacts with silver oxide in moist condition, it forms alcohol, but when haloalkane reacts with silver oxide in dry condition, it forms ether. Haloalkane ongoing reduction from hydrocarbon, commonly known by halogen attached to aromatic ring. The example of haloarine is Chloro Benzene, which is represented by this structural formula. Chloro Benzene is prepared commercially by Rathsing's process. It is also prepared from benzene. During this reaction, it follows electrophilic substitution reaction. Here the ferric chloride acts either as Lewis acid or catalyst. The properties of chlorobenzene is it is soluble in organic solvent due to diffusion, but it is not soluble in polar compounds like water, etc. For melting point and boiling point, it is directly proportional to molecular weight and van der Waals force. It possesses higher melting point than that of bromobenzene and than that of chlorobenzene. Haloarine is less reactive than haloalkane due to resonance as the double bonds moves throughout the circle and due to S character, as the S character of carbon in chlorobenzene is 33%, that is, carbon is sp2 hybridized in haloarine, whereas in alkane it is 50% S character, that is sp hybridization. Now the preparation and the chemical reaction of chlorobenzene is, first one is when benzene reacts with chlorine in dark condition, it forms chlorobenzene by following electrophilic substitution reaction. Second and the most famous one reaction is the preparation of chlorine benzene from benzene diazonium chloride. It can either be produced from two processes or two main reaction. First one is when benzene diazonium chloride reacts with copper chloride and hydrochloride, it forms chlorobenzene. This reaction commonly known as Sand's-Meyer reaction, whereas when it reacts with copper and HCl only, it forms chlorobenzene, and this reaction is known by Gattermann's reaction. When the chlorobenzene is reduced by sodium hydroxide at 300 degrees centigrade followed by hydrogenation forms phenols. This process is commonly known by Dawes process. When it reacts with reducing agent like liquid NaNH2, it forms aniline. When it goes complete reduction, it forms benzene. When the chlorobenzene reacts with Na in presence of dry ether, it forms biphenyl. When the chlorobenzene reacts with sodium hydroxide at 350 degrees centigrade followed by 300 atm pressure, it forms phenoxide. Chlorobenzene reacts with chloromethane in presence of sodium diether, it forms toluene. When it reacts with chloral, it forms DDT, that is dichloro diphenyl trichloroethane. Now that's all it for today. If you want more video, just comment down below.